Okay, so this goes along with 3.14 activity. Does a battery have internal resistance? And so it tells you to get in a dark room. Here's my dark room. It also tells you to use rundown batteries, and here are my rundown batteries down here. Now I did add a fourth battery here just to make it pop a little bit, although I think I'm going to do the first one without the fourth battery. So I'm just going to take that guy out, and then I'll show you the effect that the fourth battery has. But we've got our light bulbs just like normal. We got our positive terminal, and then we're going to one of the light bulbs, and then the light bulb is connected to this yellow wire, which is not yet touching the capacitor, and it's going to be green wire to this light bulb, and then red wire to the back to the battery. And so what we're doing is we're going to charge the 0.025 farad capacitor using round bulbs, and we're going to pay attention to the brightness of the bulbs. And so take close note to the brightness of the bulbs when I charge it. Of course, I got a little fidgety. But now we're going to pay close attention to it as we discharge it. So I'm going to leave that guy connected. I'm then going to disconnect this guy, and let's pay attention to the brightness. Now I want to do that one more time. Oh, of course I did that. So now watch carefully, okay? Here's charging. Here's discharging. Charging. Discharging. Okay? Now to me it looks like it's a little bit brighter on the discharge. Now I'm going to add another battery here to make it a little bit brighter so we can see it a little bit better, I think. I'll connect that guy like so. There's charging. Discharging. Look to see if it's brighter on the discharge. Charging. Discharging. It's becoming a little bit brighter on the discharge. So what does that mean? Well, there's got to be a higher flow rate in the discharging circuit. And so if it's going to be brighter, that means there's going to be more flow of charge, and so therefore a higher flow rate. So that means that there's got to be more resistance in charging and less resistance in discharging. And so what on earth does that mean? Well, the only difference between the charging and discharging, let's look at this. The only difference between them, if I'm going to charge it, here's what it's going to look like. I've got a battery connected to a light bulb, connected to a capacitor, connected to the light bulb, connected back to the battery. That's charging. Now discharging means I completely disconnect the battery, get rid of it, and I touch these two guys together. And so then I've got capacitor, light bulb, capacitor. And so there I go. So if it's brighter on the discharge, that means there's less overall resistance on the discharge. Well, what could be causing that less resistance? What's missing out of the circuit? It's simple. The battery is. The battery is no longer in the discharging. So why on earth would it have less overall resistance without the battery? Well, that means that the battery itself has to have some kind of internal resistance. And so this lab right here proves that the battery itself has internal resistance. And so let me make sure that you got the right answers on those. Let me scroll up to those. Scrolling. Still scrolling. So question number 2 said, based on bulb brightness, when does the circuit have more resistance? During charging or discharging? Well, I already answered that, right? The circuit would have more resistance in charging because it's not as bright. It would have less resistance in discharging because it is because the light is brighter. So what that means is, how can you account for the difference in the resistance? It's got to be that battery. There's something inside the battery itself that means it has some kind of resistance inside the battery. Then finally, question number 3 begs the question, if you notice that the beam, oh, why does it keep doing that? Hold on. If you notice that, like, it talks about a light bulb, or a flashlight, and it says, okay, flashlight. It's become dimmer than when it was brand new. So you get this brand new flashlight, and over time, after you use it, what that means is, like, it becomes less and less bright. So what's happened to the flow rate through the charge of the filament? Well, you would say probably the flow rate in the filament decreased. And therefore, because the flow rate decreased, total resistance had to increase. However, what we just observed would lead us to believe that the flashlight battery has increased in resistance over time. Not the filament, but the battery itself is what's causing that increase in resistance over time. And so when batteries get old, what happens to them and they get worn out, they basically increase in resistance so much that it doesn't allow for the pumping of charge through the circuit.